When it comes to reviewing the exam for graphical models, again, remember the most important thing is probably to redo the test, unit test for this. Okay, so the first thing that we want to talk about when we're talking about graphical models has to do with the table of values. And the reason table of values are important because we can tell from a table of values whether something is linear, quadratic, or exponential just from the table of values. And the way we do that is we do it by either first differences, second differences, or the ratios. Okay, so the ratios are the other thing that we need to look at. So what we're doing is we're taking the dependent column, and the dependent column means the y column of the table of values. Now, if I subtract the y values, and I usually start at the bottom, and they turn out to be equal, then I know that the relationship is linear. If it's not, the first differences are not equal, then I take those values that I just calculated and I do a thing called second differences. And if they are equal, then it's quadratic. And the last one is if the ratios are equal. Ratios means that I'm dividing, and you can't just say, well, it wasn't linear because first differences weren't the same. It wasn't quadratic because second differences weren't the same. Therefore, it has to be exponential. You have to prove it to me. If you don't prove using ratios, if you don't prove it using ratios, then your assumption is incorrect. Okay, the other thing that we looked at graphical models has to do with equations. Now, we should be able to look at all three different kinds of equations that we're responsible for. So a linear equation, I know it's linear if all of the variables are to the power of 1. But notice I say that there cannot be any more than 2 variables. So for instance, if I have y equals 4x, 2 variables, it's linear. If I have y equals 3, that also is linear. I only have 1 variable, but that's fine. Okay, but I couldn't have, for instance, and I'm going to erase this in a second, y equals 4x b. So I can't have 2 variables being multiplied there. Otherwise, it's not linear. Okay, quadratic. The way we know something's quadratic, if I have 2 variables and one of them are squared, so in other words, to the power of 2. So y equals 4x squared, for instance. Because the x is squared, I know it's quadratic. And the last kind is exponential. And I know something is exponential if one of the variables is the exponent. So y equals 4 to the x. So you can see the power, the exponent is x, therefore it makes it exponential. The other important aspect of this unit had to do with graphs. And again, for most of you, this wasn't an issue. So if it's linear, it's a straight line. Quadratic, it's a parabola. Now really watch out with the parabola because also the direction changes at the vertex. So for instance, if I'm only showing you this amount of a graph, you don't know whether it's exponential or quadratic at this point. But if I do the same thing and then I just put just a tiny hook that's showing it's going back up, therefore I would have to say that it's quadratic. So at this point, the first one, I wouldn't be able to say for definite sure that it was quadratic, but definitely the second one. And the last one, exponential. So remember, it's a growth or decay curve. Okay, so it doesn't have anything like this and then goes down because the problem has to do in that location there. That's why I would say that it wouldn't be exponential. Okay, so it has to go down an even, sorry, if it's decreasing everywhere. If it's increasing everywhere. I'm just going to get rid of that because that wasn't an example of it. Okay, the other thing that we need to know has to do with regression models and then using those models to answer questions. Now, when they ask for a model or they ask for an equation, you're supposed to enter the data into the calculator. Okay, so as you remember, it's pretty easy if you have the calculator keystrokes. If you don't, you're kind of in trouble. So it's important to add those keystrokes. In other words, copy them down from your notes onto your help sheet so that you have it with you. Now, where you're actually turning to make the equation, remember you have some different options. Now, I'm going to bring mine up here again. take a look. And when I go to Stat Calc, notice I have quite a few different options. So I have linear regression, which is what our note originally was on, but I also have quadratic. So if the data looks like it's quadratic, make sure you're choosing option 5. Cubic, probably not, or quartic. There's another linear, and there's number 0 is exponential regression. So you're either going to be choosing 0, 5, which is quadratic, or 4, which is linear. Okay, so don't make something linear if it's not. All right, the other thing, make sure that you know how to enter the data, create a scatter plot, and the reason you have to create a scatter plot, because obviously I'm not going to see your graphing calculator, the scatter plot, is for you to determine the type. Okay, so after you've created it, then you would compare which item is it from, sorry, from here, from number 3. Does it look like it's changing directions? Is it a straight line? Now remember, because it's a scatter plot, everything's not going to be perfect, but you should be able to make an intelligent, educated decision at what kind of relationship it is. After you've done that, make sure that you know how to make a regression model of that equation. Okay, and just don't give me the screenshot. So in other words, if you chose, for instance, linear, and I believe the screenshot for that is, just hold on, I'll bring it up again. AX plus B, and this comes AX plus B. Don't just write that down and then tell me A is 0.4723, B is negative 4.6 or 81. Don't write that down. I actually want an equation. So I want you to take that information your calculator is giving me and actually go y equals 0.4723x, because again, I'm taking the A here and I'm following what they're telling me, and then minus 4.81. So I actually want an equation, not just what you're seeing from the graphing calculator. Then you would take that equation, and in some cases you actually would substitute values in order to predict something that wasn't actually part of the data. Okay, so have good luck with that